Hello, everyone. I hope everybody is doing fine. We are here with yet another topic, that is distribution of electrons in shells. How it is exactly distributed, that is what we are going to discuss in the chapter structure of the atom. So let's quickly dive into the session without wasting much of our time. Okay. Yeah. So we discussed about that there are shells, right? Bohr actually introduced us to that. Now, Neil Bohr and Bury, they came up with, the idea that how much or a shell can take. Okay. I'm sorry. How much a shell can have, how many electrons, basically. Like, can it have 10 electrons? Can it have 1,000 electrons? How many electrons are going to be there in one shell or each shell? Okay. So why this was important was because this explains elements in the same group can have similar properties. Okay, so if same kind of number of electrons you will see at the end of each shell, they are going to show similar properties. Okay, now this will also help us to understand how atoms form chemical bonds. Okay, because we are talking about, right, this electron will be exchanged, maybe, gain of electron or lose of electron or sharing of electron is done by atoms. So how it is done and how the chemical bond is being formed, that can be explained by the idea of distribution of electrons in each shell. Okay, and what gives each element its unique characteristics, how these different electrons, number of electrons, can give actually a certain kind of characteristics to an atom or different elements, different atoms. Okay, so the shell structure is, just a second, yeah, sorry. Okay, so the shell structure, electrons orbit the nucleus in specific energy shells or orbit. So if this is, let's say, your nucleus, here the electron would be, okay, yeah, here the electron would be revolving, right? So this will be called as orbit, or you can also call it as shell. Okay, energy shell also is fine. Okay, now we'll also get to know ordered filling. Shells fill systematically from innermost to outermost. That means if there is a shell inside and this shell is also there, so this shell will be filled first, then from inner to outer, then second, and lastly third. Okay, and there is a maximum capacity. Like I told you, we cannot fill each shell with 10 electrons each. We cannot distribute electrons in between them equally. No, there is a limited capacity of each shell. So each shell has a maximum electron capacity defined by the 2n square rule that we have discussed. Again, we will discuss in depth that how it works for us. Okay, so if we talk about the 2n square rule for electrons, so we'll get to know that each shell, like I told you, right? So K is the first shell, L is the second, M is the third, and N is the last or fourth. Not exactly four, there can be more shells, okay? But so far we are talking about these, okay? So let's take 2n square again and try to figure out. So if we talk about K, okay, the first shell, so it will be having only only 2 electrons in its shell. Okay, the K shell can have, let's draw it, okay? So let me draw the electrons maybe with other color. Only 2 electrons, maximum, either one or two. Okay. Now, if we talk about, let's say this, the L shell, so 2n square is equals to, again, how many, what shell is it? 2. So we are going to put 2 and it will come out as 8. So the next shell will only be having 8 electrons to it. So let me just draw it again. Okay. So 1 and 2 and 3 and a 4 and 4 more. Okay. So these many electrons. And then again, if you will try to, figure out this, okay, let's take maybe another color. So 2n square, and this would be 3, right? Okay, sorry, you don't have to do bracket here, okay? So 3 square would be 9 and 2, so it would be 18. right? So the next shell which you make can accommodate 18 electrons into it, like that. Okay, I'm not drawing the whole electrons, but you can understand. And similarly, the fourth shell would be that will be called as N. So there are names for the shell starting from K. You have to remember that. Okay, you can't say A, B, C, D. You can't name them by yourself. So the formula would be 2 into 4 square, and you will get 32 maximum electrons in the N shell. Okay, so this is how we calculate shell capacity. Now there are few rules which we need to know. So we know that maximum number of electron rule, right? We know that each shell can accommodate a maximum number of electron, and that we have already solved. Now there is octet rule as well. That means that atoms gain or lose electron or share electron to achieve their octet. That means in each shell they are trying to complete 8 electrons. Okay. And once they do that, they are stable. And that's why they are making bonds. So now we get to know that for making bond, octet rule is there, right? And because of this only, the bonds are being made. Okay, so this configuration provides stability to similar to noble gases to every other element. Okay. Now, one more thing is you might get confused that, ma'am, we discussed that first shell is having 2 electrons in it. Second is 8, third is 18, fourth is 32. This is the pattern, right? So why there is octet rule? So this again we will discuss in our regular classes, why there is a difference in these two, or exactly is there any difference or not. Okay. So that is something for which we need time actually. Okay, now filling order. How the electrons are being filled. So electrons fill lower energy shell first, like we discussed again, right? This will be filled first, like 2 electrons will be here. Then this will be filled, okay, with 8 electrons, like this, and 1, 2, 3, 4. Okay, and then another shell. So K will be filled first, then shell L, then M shell, and then N shell, like this. Okay, and valence electron. So the electrons present in the outermost shell, suppose here, that would be turned out to be our valence electron. Those electrons either will be lost, okay, or will be the shell will be gaining electrons, or the sharing of the electrons will be done to make chemical bonds or form chemical reactions to happen. Basically, for that we have this outermost shell electrons that are called as valence electrons. Okay. Okay, so now for example, here you can see, let's take example of hydrogen. So hydrogen atomic number is Z. Z is equals to 1, sorry. Yeah, so only 1 electron is there. So if this is the nucleus of hydrogen, this will be the electron, 1 electron in the outermost shell, and that is 1 shell only, right? Because there is no need of another shells. Okay, now if we talk about carbon, let me just again change the color. Okay, so let's take carbon. So first shell will be having 2 electrons, right? But the atomic number is 6. So how many more electrons do we need to add here in the other shell? Let's see. So atomic number is 6, but the first shell can only accommodate 2 electrons. 1, 2, done. Now 4 more electrons are supposed to go somewhere. So it will come here. Again, here in the, and this is going to be, L is going to be the last shell for carbon. Now the problem is the last shell is L, and L is supposed to have 8 electrons for stability, right? So what will happen here, this carbon will start making or try to make bonds with, hydrogen or something else. From there, it can share electrons. Okay, it can share electrons to again make, a chemical bond and get stabilized. Okay, so for sodium, again, you can see sodium has 3 shells to it, 1, 2, and a 3 shell, right? And here you will see the first shell will have only 2 electrons. The second shell will be having 8. So 8, let's just draw that. So 8, 9, and 10. But we know atomic number of sodium is 11. So In large shell, only one electron is there. Okay. So this electron is ready to be given up so that sodium can achieve its stabilized state. Okay. So this is how it's done. Okay, one more thing which I would like you to know. Again, this is an like we'll discuss later also in classes. But here, if in outer shell, the electron number is less than 4. Okay, you can say it is less than 4. So it is ready to lose electron. The whole element is ready to lose electron. If it is equal to 4, so it can share electron, mostly in most cases. In some cases it can be different, that I'll tell you. And if it it has more than 4 electrons in its outer shell, it's ready to gain electron. Because see, it's easy to lose this one small electron than gaining a lot of 7 electrons, right, from someone. Okay, you can ask somebody for a small amount of money, but asking too big would be difficult, right? So this is the case here, like here also. And in this case, suppose if it is more than 4, so then you can't lose it. Then you will take it from somebody, okay? So you will basically, what you will do is, what atoms will do, atoms will take electrons, more electrons here, if already more than 4 electrons are there. So maybe they'll take 3. So here the valency would come out as 3. Okay, like that. So this again we will discuss in detail. Okay, or if you have any doubt, you can ask me also. Okay, so why is electron distribution is important? It tells us the chemical properties of each element. If you are able to find out the electron distribution, how it is distributed, you'll be able to tell whether it is a metal, non-metal, a noble gas, or what exactly it is, and its property as well according to that. Okay, you can arrange them periodically according to their atomic number, right, and according to their valence electrons. And also you can tell what sort of bond it can make. Can it share can it make shared bonds? Okay, or can it, it has to lose electron to make bond, or does it have to gain electron to make bond? So all these things could be, dealt here. And with this, we come with, we come to questions now. So the first one is, I hope this is clear. Okay, if any doubts, you can always reach out to me on my Urban Pro profile, or you can just comment down and I'll just try to answer those questions. Okay. So here, the first question for you would be, what is the formula to calculate maximum electron in a shell? I hope you'll be able to do this easily now. Question 2 is, how many electrons can the L shell hold? And the last is, the outermost shell of an atom is called as core shell, valence shell, energy shell, or proton shell. So you can think, and we can discuss maybe in regular class also if you have any doubt, or like I said, you can comment. Okay. So to summarize everything, we have learned about the 2 and square rule. Sorry, you can go back and answer your question now. And we learned the shell filling order, that K is filled before L, L is filled before M. So there is an order being followed here. And we also learned a little bit about the valence electrons, that how does, valence electrons are there. So thank you so much for joining the session. I hope you enjoyed and learned. And if you have any doubts, you can again connect me where I am, right? So thank you so much. Take care. Bye-bye.